All right, welcome back to pre-calculus. So we're going to go through a couple of homework problems here and see how well we're going to do with this. Oh, excuse me. All right, so this will just be a walkthrough. First couple of problems I will add to this as we go through. All right, so we're going to start solving equations and see what's happening here. All right, so we have y is equal to x squared minus 4, and then we have 3x minus y is equal to 4. Okay, so they're going to tell you, right, use the substitution method. So at least the first couple of problems, that's how that's going to go. Okay, we've got a parabola, right, that opens down. So it's nice to, I mean, we're not trying to solve this by graphing. All I'm trying to do is figure out, like, well, how many solutions am I expecting? And then here we have a line, right? We have, this is y is equal to 3x minus 4, right? If I push this on the other side and kind of shuffle. So let's see here, 1, 2, 3, 4. So my intercept is minus 4. And then we are doing one quack, or one waddle, and then 3 quacks all the way up. So 1, 2, 3. So we're looking at something like this. Okay. I had a teacher in high school that when he would graph, right, the x values, these were waddles, and then the y values were quacks. So it's just something that I've always remembered. So hopefully you will too. Okay. So waddle, quack, 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 waddle, quack, quack, quack. All right. So I expect two, right? I expect two solutions here because this is going to come down, and no, down here somewhere they'll intersect. Okay. All right. So let's see here. We've got y is equal to, right, y is equal to x squared minus 4, and in here we have y is equal to 3x minus 4. Okay. So why don't we say that y is equal to y, and we could do something like x squared minus 4 is equal to 3x minus 4. All right. So at that point, let's go ahead and push this to the other side. So we've got x squared minus 3x, and I'm going to add 4 to both sides. And we're just going to have, right, negative 4 and positive 4, that make 0. So we have x minus 3 times x is equal to 0. And my solutions so far, x equals 0, x equals 3. All right. Now, what's y going to be? Well, you can pick either of these two equations all the way back up here. You can pick either of these two equations or any other representation of those equations to plug it in for y. I'm going to pick the line because I think lines are easier. Okay, so this was y is equal to 3x minus 4. Y equals 3x minus 4. So when x equals 0, right, y is equal to negative 4. When x equals 3, then y is equal to 3 times 3 minus 4, 9 minus 4, y is equal to 5. Okay, so my two solutions here, 0, negative 4, and 3, 5. All right. So, I should have looked. Okay, they tell us to graph it anyway, so be it. All right, so we're going to go ahead and graph. That's going to be, right, 4 minus x squared, and it looks like we're going to have, oh, opens, and it looks like we're going to have 2 and 2. Okay, double check. Oh, x squared minus 4, so I'm off. Here, vertex, and then our intercept are going to be 2 and negative 2. All right, kind of tell that by inspection. Okay, and then we have a line, right, and we have negative 1, 2, 3, 4. All right, and then, right, we said y is equal to 3x minus 4. So we need 1 waddle and then 1, 2, 3 quacks. Okay. And we've got that, and then we'll just check. Okay, are they happy? They're happy. So technically this one, we probably could have just solved by, you know, so wow, did I mess that up? It did. The previous one had a negative x squared. Sorry about that. This was a terrible picture. All right, it should have been something like this. It's still a terrible picture with our line. Okay. Where am I? Where's my head today? All right, so fixing that. Okay. Then we get our substitution method. All right, so we're gonna tell it to set, right? And then we want the two answers that we got. Okay, and those answers were 0, -4. 0, -4. I know from experience that if you forget the little brackets there, it warns you, but it doesn't mark you wrong. Okay. What's the other one here? Is 3, 5. So there we go. All right, it's happy, and we can move on to the next one. All right. Okay. Beautiful. I think the one I had previously was a little bit harder. I'm going to go back to that one. I was just hoping for a slightly more difficult problem because the one I just did earlier was a slightly more difficult problem. Let's see if we can get a better shuffle here. Yeah, I know. I don't know if you guys have access to that button. Okay, but we're going to go back down here and we're going to say try it again. All right. I was kind of hoping that we would get the harder one. No, it's not going to give us the harder one. Let's try one more time. All right. Try another. There we go. Okay, that's what I wanted to see. Because I didn't want just the square root of x here. I wanted something a little bit more juicy here. Okay, a little bit more interesting. All right, great. We've got x squared plus y squared is equal to 82. We have y is equal to the square root of x minus 8. And again, we are going to substitute, okay? This is nice because y squared, right, is equal to x minus 8. So here we go. We've got x squared plus y squared, that's square root of x minus 8 squared is equal to 82. Okay. So we have to solve this. This is going to be x squared plus x minus 8 because we squared the square root is equal to 82. Subtract 82 from both sides, and we get x squared plus what is 8 minus 82. 8 minus 82 minus 74. Okay, that looks delightful. Let's see here. Divided by 2. Really? Wow, this is going to be a delightful problem. Okay. Wait, it's negative 8 plus, okay. Let me not get excited on that one. So 8 and 82, that's going to be 90. Okay, I'm a little bit happier. And the reason why is because we've got to solve this. Minus x, nope, plus x. Minus 90 equals 0. So I got to come up with how to factor this. All right, not so bad. All right. Let's go ahead and graph this thing. Even if it's not going to be graphed on a computer, I can still make a sketch, right? So we have x squared plus y squared is equal to 82. This is the center with the square root of 82 as a radius. Square root of 82, 9-ish. So let's call that 9. So we're just going to have a circle centered at the origin, right? Pretend that that's round. Okay. And then we have this y is equal to x minus 8, square root. What's the square root function with a shift to the right, at 8? So here. And then it's going to look something like that. The only solution we have is in that first quadrant. All right, I'm going to look at this and I'm going to say, well, this is nice, but that square root is not over here. Okay, so the only solution I think I have is this one, when x equals 9. Well, if x equals 9, right, y is equal to, square root of x minus 8. If x is equal to 9, then y is equal to the square root of 9 minus 8. Y is equal to the square root of 1. All right. Again, I know it's in the first quadrant. All right. I don't have to mess with anything else. So my solution here, is x is equal to 9, 1. Right. That's my solution. Let's see how to work it on a computer. All right. We have to graph this. All right. At this point, x squared plus y squared is equal to 82, and I do my circle, okay, here's the center, and we need another point. That's going to be kind of rough, right? So what we're going to do is we are going to pick any point on the circle, but I'm going to plot it. So if y is equal to 0, we'll do x is equal. If x is equal to 0, then y is equal to the square root of 82. So what we're going to do is we're going to say x is equal to 0, and then y is equal to the square root of 82. We're going to say plot that point. Okay. You see how we got an answer, sort of? So now when I go to do my circle, I've got an x to aim for, and it'll allow me to actually graph this thing accurately without having to approximate any of this, because it won't let you. Okay. Oh, and if you type in Control and plus, that will zoom into this thing, so you might have an easier time trying to get this point. But yeah, I would plot it first and then go ahead and do that. So this one, we know it starts at 8, and then when x was 9, then y was 1, so we have to only go 1 over. But again, I could have plotted something, If you pick 10, we'd have the value x is 10, y is the square root of 2. All right, and we'll check that answer. All right, are we happy? They look happy. Oops, I want to go down. There, we're zooming back. No, we're not. There, okay. So, yay, we're happy. Okay. And then the solution set. And again, they want you to do that. They're not going to mark you wrong if you don't, but they will yell at you. Okay, we have 9 and 1. 9, 1. Answer. Hooray. All right. Let's do one more. And we'll call that good for this section. Let's see, we've got this thing versus that thing. Okay. So let's see here. We've got y is equal to -3 times the cube root of x, or y is equal to -3x. All right. So let's see here. If y is equal to -3 root 3x, and then y is equal to -3x. So -3x, that line looks like this. Okay. Now, normally, let's see, cube root. What do I know about cube roots? Cube roots, let me do something that's slight. Cube root tends to look like this one, Something like that. But it's flipped, so it's down here, because it's also an odd function, and it's scaled. So my slightly more bolder choice here is going to look something like this, and like that. All right, so I'm expecting 2 solutions here. So let's see what happens. Actually, I'm expecting 3 solutions. All right, so let's see what happens here. Let's go back to a nice bold term. Back to that. All right, so what we're going to do is we're going to set y equal to y. So we have negative 3x is equal to negative 3 times the cube root of x. Well, I think we can safely take out the negative 3's. And then we have x is equal to the cube root of x. I don't want to do the cube root of x. I just want that. All right, so we have x cubed is equal to, right, the cube root cubed is going to be x. And then we can just solve from here. Right, x cubed minus x is equal to 0. We have x minus 1, x squared minus 1. So we have x equals 0. We have x minus 1 equals 0, and x plus 1 equals 0. We just factored this. All right. So my three solutions here, x equals 0, x equals 1, x equals negative 1. All right. What's y equal to? Y was equal to negative 3x. Okay. So when x equals 0, y is equal to 0. When x equals 1, y is equal to negative 3. When x was equal to negative 1, y is equal to positive 3. All right. So these are my three solutions. Let's go ahead and run through the computer so we make sure we get all the little pieces right. So graph, 5 points on the graph. Oh my goodness. All right. So let's go ahead and start that. I know 0 and 0 is one of them points, so we'll say to plot that. Okay, when x is 1, okay, when x is 1, the cube root of 1 is 1. 1 times negative 3 minus 3. Okay, plot. All right, now we got to pick another point, and it's better be one that's in this region, because I know if I pick something that's over here, it'll tell me it's out of bounds and it won't like it. The next easy cube root, right, is 8. So the cube root of 8 is 2. 2 times negative 3. Okay, so we have 8. And 2 times negative 3 is going to be negative 6. Right? Again, negative 6 is going to be here. Now, did you notice that this was an odd function? Okay, so since it's an odd function, we know that f of negative x is equal to negative f of x. So I picked 0, which negative 0 doesn't, it's not really a thing, but I picked 1 and 8. So over here, right, we're going to be able to pick negative 1 and negative 8, and it's going to be the opposite, right, the opposite of what it was over on this guy. So this is going to be negative 1, oops, negative 1, 3. See, you know, try to use something that we learned before, and we can try to be clever. And then 8, and then watch it backfire on me. That's negative 8. Okay, negative 8. There we go, plot the point. All right, let's go ahead and draw. That looks pretty good. Check that answer. All right. Oh, okay, it gave it this to me, and now it's going to say graph negative 3x. All right, does it tell us? No, we only need 2 points. So here, and then 1 waddle, 1, 2, 3 quacks. Okay, there. Negative 3x. Check. All right, so pretty happy. Solve the system by substitution. So we have got 1, we've got a 0, 0 point here, comma. We have another one, which was, right, negative 1 and negative, oh no, positive 3, right? Look at our graph here. And then we have 1, and now we have negative 3. Right. Check our answer. Oh, did not like this. What? All right, we have 0, 0. We have negative 1, positive 3. We have 1 and negative 3. What are we? Right, those are the 3 that we got, right? 0, 0, 1, -3, -1, +3. What are you saying? Oh, I didn't put a comma there. I'll bet that'll fix it. My goodness. All right. I believe me, I empathize greatly with you guys when you're struggling with this thing. It could be very difficult. All right. So let's go ahead and stop it there. That way it keeps the video small. So I'll leave you to do that one on your own. Okay. And we'll pick up we'll set up the elimination ones next time, but we'll go with that. All right. So take care. Good luck to your homework, and we'll be good.